Number 7 from February, March 2018, paper 4, variant 2, question again about grouped frequency tables and finding the mean and such. I said I would answer the questions from this paper which haven't come up in the paper 2 for 2018 June, so I will answer this question as well. Find the probability that one of these people, okay, the frequency table shows information about the time, m in minutes, that each of 160 people spent in the library. Okay, so what this means is there were 3 people that took or spent between 0 and 10 minutes in the library. And there were 39 people that spent between 10 and 40 minutes in the library. And 43 people spent between 40 and 60 minutes in the library, and so on. So it's a group frequency. So we don't know how much time these 3 people each spent in the library, but we know that the time they spent in the library was somewhere between 0 and 10 minutes, okay? So one of them could have spent 2 minutes, one of them could have spent 10 minutes, one of them could have spent 5 minutes. We don't know. Okay, we just don't know. Okay? We have to find the probability that one of these people chosen at random spends more than 100 minutes in the library. So we look to see these 9 people spent more than 100 minutes, between 100, more than 100 and less than 120. So there's 9 people out of a total of 160. That's your answer. Okay, that one of these people spent more than 100 minutes, as simple as that. Okay, part 2 says calculate an estimate of the mean time spent in the library. And as I mentioned in other videos, it's called an estimate of the mean time because we don't know how much, we cannot find the mean. We don't know what number, we don't know the data to add together. So the mean is when you have all the data, you add each data item together, add all the data items together, get the total sum of all those items of data, then divide by how many items there were. Okay? So you add the values of the data items and you divide by how many there were. Now we know that there are 160 people, so we know to divide by 160. But we don't know what the sum of all the data items are, so we have to do what's called an estimate. So to estimate, we have to find what's called the mid-interval value. So right up here, mid-interval value, which is a halfway between each of the groups. So for example, these 3 people spent between 0 and 10 minutes, we say they spent 5 minutes, so that's going to be 5, halfway between them. 39 people spent between 10 and 40 minutes, so halfway between 10 and 40. But if you're not sure, you add them together, gives you 50 divided by 2, which is 25. It's halfway between them. Halfway between 40 and 60 is 50. Halfway between 60 and 90, well, if you add them together, you get 150, divided by 2 is 75. Halfway between 90 and 100, well, that's 190 divided by 2, okay, which is 90. 190 divided by 2, which is 95. Yeah? 190 divided by 2. Yes, basically 95 is halfway between these two. You can see that. 100 and 120 is going to be 110. Okay? So that's how you find the mid-interval value. So now we know what to multiply these numbers by. So I know that 3 people, we don't know how long they spent in the library, okay, but it's somewhere between 0 and 10 minutes, so we say it's 5, just to give us something in the middle. 3 times 5 plus, we do the same thing here, 39 times 25 plus 43 times 50 plus 55 times 75 plus 11 times 95. Whoops, what did I write there? 11 times 95. And finally we have 9 multiplied by 110. And that's going to all be over the total number, which is 160. 160 people. If they didn't tell you the total number, you'd have to add these together, add the frequencies together, that'll tell you how many people were spent time in the library. Okay, so now we can just basically use our calculator to multiply these things together. We calculate it first. 3 times 5. 3 times 5 plus 39 times 25. 39 multiplied by 25 plus 43 times 50. 43 multiplied by 50. Okay, plus 55 times 75. So plus 55 times 75. Okay, then move this out of the way. 55 times 75 plus 11 times 95. And then plus 9 times 110. Okay, 9 times 110. And there we have, okay, the total, which should be 9,300. And you divide that by 160. So you have 9,300. Okay, so that's going to be 9,300 divided by 160. Okay, and there we get our answer. It gives us 58.125. Okay, 58.125. 58.125, which seems correct. Now what you should notice is, if your answer comes out as like, 150, there's no way it can be correct, because the mean has to be somewhere in the range of these values. Okay, so be sure that if you come with a question which is outside, your answer comes outside of the range, then there's definitely some problem. Okay, so now I'm going to finish off. No, I'll do part B in the next part of the question. Okay, thank you for paying attention. Okay, one more point, sorry. Here this came out as an exact value. If you see in a calculator, it stopped right there. Okay, so what we have is, we have the option of rounding to 3SF, but it'd probably be better here to leave it in its exact form. Okay, because this is an exact answer, so it's perfectly fine to do that. Unless it said, give your answer to the nearest minute or something like that, you can leave it in its exact form. Because this is classed as an exact answer. Okay, and especially topics like limits of accuracy, which already came up from paper 2, but especially topics like that, you do always try to leave it in exact form if that exists, even if it's 4 or 5 decimal places. Here, 3 decimal places, that's fine. You can leave it, or you could round it. Both would be accepted, but I guess it's better to round it. It's better to leave it as exact. Okay? All right, thank you.